Hey everybody, thanks for joining me today. Today we're going to take a look at multiplying binomials. So just remember, a binomial is an algebraic expression with two terms. So this is a binomial because it has two terms inside the parentheses there. So in our first example, what we're going to do is just find the product. So remember, if we're multiplying a monomial by a binomial, all we're going to do is use the distributive property. So when we do that, we're going to take the 7 and multiply by everything inside the parentheses. So 7 times b and 7 times -2, and so we get 7b minus 14. Okay, I know we've already done that, so it should be an easy problem to do. Okay, the next one, 9k squared times 3k plus 1. So remember the rule x to the a times x to the b is equal to x to the a plus b. So in other words, what that's saying is if we have like bases, what we're going to do is just add the exponents. So in this case, this has an exponent of 2, this has an exponent of 1. So we're going to add those exponents together when we multiply those terms. So here we have 9k times, we're just using distributive property again, so 3k plus 9k squared times 3k plus 9k squared times 1. And so we can simplify this 9k squared times 3k. 9 times 3 is 27. K squared times k is k to the third power, or k cubed. Plus 9k squared times 1. Well, 9k squared times 1 is just 9k squared. So 27k cubed plus 9k squared is our final for that. Okay, so next, we're just going to take a look at factoring real quick. So we're just going to factor a common factor out of each expression. So this is just kind of a reminder of how to do that. So in our first one, 40x cubed minus 28. So remember, what we have to do is find the least common divisor between, or LCD, of the terms. So the LCD of 40 and 28 is just 4. So we're going to factor out a 4 from each of those terms. So when we factor a 4 out of this, 4 times 10 gives us the 40. So basically, it's like dividing 4 from this. So 40 divided by 4 is 10. 28 divided by 4 is 7. So when we factor out a 4, we get 4 times the quantity, 10x cubed minus 7. Notice there is no x term in both of these, so we cannot factor out a variable at all. So this x cubed just stays right with the 10. Okay, in the next example, we will have a variable that we can factor out, however. So 60r to the fourth plus 50r cubed plus 90r squared. And so we're going to find the LCD of 50, 60, and 90. So find the LCD of that. And then we're going to find the LCD of r squared, r cubed, and r to the fourth. So first, the LCD of 50, 60, and 90, well, that's 10. We can take a 10 out of all three of those numbers. So the 10 is going to go out front. The LCD of r squared, r cubed, and r to the fourth, of course, is r squared. So we're going to take an r squared out to the front. So we have 10r squared times a quantity. So if we divide this by 10r squared, 60 divided by 10 is 6. R to the fourth divided by r squared is just r squared. 50 divided by 10 is 5. And r cubed divided by r squared is just r. And in this one, 90 divided by 10 is 9. R squared divided by r squared is 1, so the variables end up canceling out. So we end up with 10r squared times a quantity, 6r squared plus 5r plus 9. Okay, now for the most complicated example of the three. 18x squared y to the fourth plus 6x squared y to the seventh minus 54x to the fourth y to the sixth plus 30x to the fifth y to the sixth. This one looks really complicated, but we're going to do it the exact same way we did before. Find the LCD of all the numbers. So the least common divisor of 18, 6, -54, and 30, well, that's 6. That's the biggest number that we can divide out of all four of those numbers. So we're going to bring a 6 out front. the LCD of x squared, x to the fourth, and x to the fifth, well, that's x squared. So the x squared is going to go out front. And the least common divisor of y to the fourth, y to the seventh, y to the sixth, and y to the sixth is y to the fourth. So we're going to take the y to the fourth out to the front. So we're going to divide all four of these terms by 6x squared y to the fourth. Okay? So 18 divided by 6, well, that's 3. X squared divided by x squared is 1, so the x's cancel out. Y to the fourth divided by y to the fourth is also 1, so the y's cancel out. So notice the only thing left here is just the number 3. Okay, moving on to the second one. 6 divided by 6 is 1. X squared divided by x squared is also 1. So the number canceled, the x squared's canceled. Y to the seventh divided by y to the fourth is just y to the third. So we're left with just y to the third there. Now, just bring down the negative sign. 54 divided by 6 is 9. X to the fourth divided by x squared is x squared. And x to the sixth divided by x to the fourth is y squared. And then in the last one, 30 divided by 6 is 5. X to the fifth divided by x squared is x cubed. X to the sixth divided by y to the sixth divided by y to the fourth is y squared. Okay, one thing that you will notice here is that none of the sets of the variables are the same. So there might be a temptation to try to combine some of these terms, but since, for example, here this is x squared and this is x cubed, we can't combine those terms. They're different terms, so they don't combine. Only if this was x squared y squared and this was x squared y squared would those combine together. Okay, so none of these are like terms. We can't combine any of them together, so this is our final answer right here. So we're done with that problem. Okay, moving on. So what we're really working on today is multiplying binomials. And we have 3 different methods of multiplying 2 binomials together. First method that we will do is using a table. So using a table will help you to keep your work a little more organized. So let's just take a look. How we set that up, we're going to find the product of p plus 5 times p minus 5. So to set that up, take your first term and put it along the top of our table, and take the second term and put it down the side of our table. Now the one thing to be careful here is not to lose that negative sign. We do have to have the negative sign from this term right here. Okay, so be sure not to lose any negative signs. If this were a negative, it would just go minus 5 right here. Okay, so now we have our table. We just have to fill in our table. So each of these boxes, basically what we're doing is we're finding the area of each box. So remember, area is just length times width. So this area, because this length is p and this length is p, p times p is p squared. P times 5 is 5p. P times negative 5 is negative 5p. And 5 times negative 5 is negative 25. Okay, so good setup. Now what we have to do is just rewrite everything. So p squared plus 5p minus 5p minus 25. And now that we have that, we can just combine some like terms. So plus 5p minus 5p, well, those cancel out and become 0. So in this case, we can cancel those out. Those won't always cancel out, but in this case they do. And so that leaves us with p squared minus 25. And that is the product of p plus 5 times p minus 5. Okay, next method is using FOIL. So the FOIL stands for first, outside, inside, last. You might remember using this one in Algebra 1. So we are going to find the product of 2x plus 2 times 3x minus 5. So I've kind of laid it out here so you can kind of see what we're going to be multiplying here. So when we go with f, f stands for first. The first terms are 2x and 3x. So I have those highlighted here. When we multiply 2x times 3x, we get 6x squared. O stands for outside. Outside terms are 2x and negative 5. So 2x times negative 5 is negative 10x. I stands for inside. Inside terms are 2 and 3x. So when we multiply 2 times 3x, we get 6x. And L stands for last. The last terms are 2 and negative 5. When we multiply 2 times negative 5, we get negative 10. So again, rewrite and combine like terms. So 6x squared minus 10x plus 6x minus 10. Again, when we combine the negative 10x plus 6x, we get negative 4x in the middle. So we end up with 6x squared minus 4x minus 10. Okay, our last method that I will show you is multiplying vertically. So multiplying vertically might seem a little intuitive if you remember how to multiply two two-digit numbers together. So first, let's look at this example. If we take 15 times 23 and we line them up like that, remember we go 3 times 5, which is 15. So we would write the 5 and carry the 1. And then 3 times 1 is 3 plus 1 is 4. And then remember we have to put a 0 here. And then we multiply the 2 times the 5 and the 2 times the 1. So 2 times 5 is 10. Carry the 1 again. 2 times the 1 is 2 plus 1 is 3. So we end up with 300 plus 45, so 345. Okay, so hopefully that's a good refresher of how to multiply two two-digit numbers. So we're going to multiply 2x plus 5 quantity squared. So remember that when we have this squared here, this means that we're taking this thing right here and multiplying it by itself. One common mistake that students make is that they take this squared here and square this and square this. And what happens is you miss that middle term when you do that. So be careful. This is 2x plus 5 times 2x plus 5, not 2x squared plus 5 squared. Okay, so we're going to take 2x plus 5 times 2x plus 5. So just like what we did up here, we're going to take the 5 and we're going to multiply it by this. And we're going to take the 5 and multiply it by this. The nice thing about this is we don't have to carry anything. So when we take 5 times 5, we get 25. And 5 times 2x, well, that is 10x. There is no negatives in here, so just make the plus. If this had been minus 5 and plus 5, we would have made that negative 25. But since they're both plus, we make it plus 25. Okay, so what did we have to do up here? Well, we had to put in a 0 as a placeholder. So we're going to go ahead and do that. Put in a 0 as a placeholder. And now we go 2x times 5, which is, once again, 10x. And that's positive 10x. And then I'm going to go and I'm going to multiply 2x times 2x, which is 4. X times x is x squared. So we get 4x squared there. Okay? And now what was the last thing we did up here? We added straight down, right? So we're going to do the same thing here. We're just going to add straight down. 25 plus 0 is 25. 10x plus 10x is 20x. And 4x squared plus 0 is just 4x squared. So we get 4x squared plus 20x plus 25. And that's it. We're done. So that is a great review of multiplying two binomials. I hope you enjoyed that, and have a great day.